Hello friends, welcome to my channel. Hope you are doing great. If you haven't subscribed to my channel yet, please go ahead and subscribe. I have created bunch of playlists to cover various categories of the problems such as breadth first search, depth first search, dynamic programming and so on. Please check them out in the playlist section. I have uploaded the code for this problem to the GitHub repository. You can get the link from the description below this video. Today's problem is invert binary tree. Invert a binary tree basically. So the input given is as shown in the picture with 3 levels and the binary tree with the root node at 4 and the left child and right child are 2 and 7 and so on. Basically for 2 left child is 1 and 3 and 7 left child is 6 and 9 left and right child, right? So basically at every level we have to invert the contents of the binary tree, right? So if you look at the output, right, so root node there is no reversal, right? So inverting means basically you are going to swap the left subtree and right subtree, right? So you will swap the left subtree which is there as 2 and right subtree as 7, right? So you swap both of them, so 7 will be left and 2 will be onto the right, right? So at that point in time all the contents, all the subtree of 7 will be moving to 4's left child and all the subtree of 2 like 2, 1, 3 will be moving on to the right child as 4, right? So at that point in time 6 and 9 will be flipped, so 9 will become 6 and 6 will become 9, so that's what it is, right? So 3 become 1 and 1 become 3, right? So that's what it will be. So basically what we are trying to do here is we are going to flip the left child and right child at a given node, right? So we can do this with a simple recursive method. Basically as long as you store one of them in a temporary variable and flip the pointers, that's it. So we are not going to change any content in the binary tree or whatsoever. All we are going to do is flipping the pointers in the binary tree, right? So let's go ahead and look at the code for this particular problem, right? It's simple recursive algorithm. So basically you have I have the private method which is going to really do the inversion, right? So if the root is null, then we don't have to do anything, just return, that's it. So if the root is not null, right, so then what we are going to do is store the left child in a temporary variable and put right child into the left child, right, and put temporary variable whatever we stored into the right child. So we have done that at the root level now, right? So now what we are going to do is do the same process at the left child and right child also. So that's what we are going to pass. So invert at left child and invert at right child. So this will take care of inverting the entire binary tree, right? So finally once this is done, once the call exits, right, you just return the root, right? So whatever the root that is present, we just return the root. So at root you don't have to invert anything because there is nothing that you can do for the root, right, since it is a single node. But all other nodes at the below the root level, right, you will have to do the inversion like in the simple 2 steps, right? So first you copy the left child and put the left child into the right child and then be done with it, right? So these 3 steps, that's it, nothing much. This is just a simple flipping between 2 variables, assuming, right? So the variables here are left child and right child, right? So let's go ahead and look at the time and space complexity for this particular problem. So space and time, right? So how much time it's going to take? So since we are doing at all the given nodes, right? So for example, if the node has if the tree has n nodes, let's say, so if the tree has n nodes, right? So the time complexity we are going to do at every single node in the binary tree as long as the tree or the child nodes are non-empty. So that means time complexity will be order of n at a given node, right? So what is the space complexity? Are we using really any space complexity here? So not really, we are not using any external space. So we would just say order of 1 is the space. So this algorithm is the order of n and constant space algorithm, where n is the number of nodes in the particular binary tree. So we are able to solve this problem with a simple recursive method. If you have any further questions, you can post them in the comment section below this video. I'll get back to you as soon as I can. You will be able to find the link for the code in the GitHub repository. The link will be in the description below this video. If you haven't subscribed to my channel yet, please go ahead and subscribe and share among your friends as much as you can. Please click on the bell icon so that you will be notified about my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe and goodbye.